Hello guys, in this class, let's now talk about our electrostatic 2. In the first class, we'll talk about, in the last topic, we'll talk about electrostatic 1. We'll talk about what's electrostatic, talk about method of transfer by friction, contact, induction, talk about your electrophorus, your gold-leaf electroscope, your Van der Graaf, and so on and so forth.
Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons, you have access to your notes, you have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy.
In this class, we're going to talk about electrostatic 2. And electrostatic 2, we're going to cover the following. Number one, we'll talk about what is Coulomb's law. We'll go for that to talk about electric field. We'll talk about electric field before when we introduce charge, right? We'll just talk about electric field with its relation to Coulomb's law. Talk about the calculation of electric field. We'll go for that to talk about your electric or dipole. Well, during my course of the teaching, I told you that magnetic field, electric field are dipole. Why are they dipole? Because they consist of two poles, right? For magnetic field, we have the north and the south pole. For electric field, we have the positive and the negative. We'll go for that talk about what electric flux, the number of field lines passing through what an area. We'll go for that talk about what Gauss law. Gauss was the one that showed the relationship between your charge as well as your permittivity. We want to talk about that. After that, we'll go for that talk about your electric potential. And we'll go for that talk about your electron volt. Very important, electron volt. We need to talk about that. Do you understand? So these are the things we're going to cover in electrostatics 2. Are you set? Let's go for that. So our first lesson, which will be our lesson 1, we're going to talk about your Coulomb's law. Now, I'll start by telling you that a man known as Charles Coulomb was the one that gave a relationship between your force, between your charge, and between your distance between the charge. That means three things. He gave the relationship between your force, your charge, and your distance. These three things. And he gave it in a law. And that law is simply called what we call the Coulomb's law. What does Coulomb's law state? Coulomb's law says that the force of attraction or repulsion, that would not be there. The force of attraction or repulsion between two charges, Q1 and Q2, is direct proportional to their product and inverse proportional to the square of their distance apart. Just the way we have your Newton's law, we see that Newton's law says that the force of attraction between two masses, M1 and M2. Are you seeing that? So in Newton's law, it is the force of attraction, but in Coulomb's law, it is the force of attraction and repulsion. So either it is attraction or repulsion, but in Newton's law, it is just only what attraction. Do you understand? Everybody, what do we see is your Coulomb's law? It says that the force of attraction or repulsion between two charges, so that the charges Q1 and Q2, is direct proportional to their product and inverse proportional to the square of their distance apart. This says that the force of attraction or repulsion between two charges Q1 and Q2 is direct proportional to the product of their charges and inverse proportional to the square of their distance apart. Well, everybody, what is it? Coulomb's law says that the force of attraction or repulsion between two charges Q1 and Q2 is proportional to the product and very proportional to their distance apart. Do you understand that? That is simply what we call the Coulomb's law. Now, from here, let's see. Look at it. The force of attraction is direct proportional to charges Q1 and Q2 and proportional to the square of their distance apart. So if you want to put this, you can say that F is equal to K Q all over R square, where your K is called your constant, which is giving us 9. First of all, K is giving us 1 over 4 pi E naught. Are you seeing that? So K is equal to 1 over 4 pi E naught. This simply has 9.0 times 10 raised to power minus 9. Or 10 raised to power 9. Do you understand that? So everybody, what is Coulomb's law? Coulomb's law says that the force of attraction or repulsion is proportional to the product of their charges and proportional to the square of their distance apart. This force is proportional to what product of charge. That same force is proportional to the square of their distance apart. Do you understand? Close that one more time and tell me, what does Coulomb's law state? Say that the force of attraction or repulsion between two charges Q1 and Q2 is proportional to their product and inverse proportional to the square of their distance apart. Now,
so when it comes to creating an account, right, this is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this: as a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you have put in your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for Jamb or Waec. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and Waec, click Waec Jamb Pursue TME, right? As the select education. Select level. You are not preparing for Pursue TME, you are preparing for Jamb and Waec, right? Okay, click on the what? Jamb and what? Waec. And then create your account. 2 seconds. Plus, you don't enter. It will load and then it will open for you. And it will tell you, welcome, John, right? Your classes are now what? Ready. What do? Start learning. Still on Coulomb's law, I would like you to know that mathematically you see F is proportional to Q1, Q1, Q2 all about what arrow square. From there we said that F is given as KQQ, where we said the K is said to be what? The constant. Where F is the force, Q is the charge, arrow is the what? Is the distance. Now take note that we'll go further to talk about that the K is equal to 1/4 pi E0, which is 9.0 times 10 to the power what? 9. Now we can prove this. Very simple. It now means if I want to prove this 1/pi, pi is 3.142. What of E0? E0 is a constant, but that's permittivity of empty space, which is 8.85. Take this to be what? 8.85 times 10 raised to power 12. 8.85 times 10 to the power minus 12. So that's permittivity. So if you put 1/4 times 3.142 times 8.85, you're going to get approximately this value. That's how we got the law. Do you understand? Do you understand? If you say you understand that, take note that electrostatic force is vector. Now, on that electricity, now we have listed two things that are vector. Number one, electric field. Electric field is vector. Electrostatic force, electrostatic force is what is vector. We'll talk about charge, all of that. We say those ones are what they are said to be what scalar. Now, if they are vector, it means they have magnitude and they have direction. And because they have magnitude and direction, take note about what time by electrostatic force is that it obeys the law of superimposition. What does the law of superimposition mean? It states that the net force is equal to the sum of the individual force. That means if we say our total force is 5, how do we get 5? Let's say 1 was 3, another was what? 1, and that was 1. So if you plus 1, if there are 3 charges, Q1, Q2, Q3. If you plus 3, this 3 plus 1 plus 4 is equal to 5. This is the F net. That means the net force. Are you seeing that? So because the net force is equal to the sum of the individual force, we say that force Z will be what? Superimposition. Do you get what I'm trying to say? Taking our electrostatic force obeys the law of superimposition. What does that law state? It states that the total force is equal to the sum of the individual forces. And we can give that by mathematical equation. We can say that F1 is equal to F21, F31, F41. Are you seeing that? This arrow there shows that it has direction. For it to have direction, it's a vector. A vector quantity is one that has magnitude and direction. From this arrow, you can see that it has what direction. Are you seeing that? Do you understand that?
I hope I'm not too fast. Now, if you say you understand that, still on your Coulomb's law, I'd like you to know that we said that Coulomb's law can either be attraction or repulsion. Where will repulsion come when they have what same charges? So if the charges are positive and positive, it will be repulsion. Or if they are negative, it will be what repulsion. Of course, we say that like charges repel, right? Now, but if they are opposites, it will be what attraction, right? So let's say, for example, we have negative and we have positive. What can you see? Attraction. So that's how we say Coulomb's law says that the force of attraction or repulsion, force of attraction or repulsion, force of attraction or repulsion between two charges Q1, Q2, repulsion, the product of the charges and vibration is the square of that distance weight apart. Do you understand that? That's it. Let's take past question. We're given that two charges Q is equal to 3 that's microcoulomb, 3 microcoulomb and minus 6 microcoulomb are separated by a distance. The question says that calculate the force and the nature of the force. They give us K. Now, very simple. Know that from Coulomb's law, F is equal to K Q all over R squared. So the force here will now be equal to K, which is 9 times 10 raised to power 9 times 6 times 3 times 10 raised to power minus 6 times 6 times 10 raised to power minus 6 all over what's the distance here? Convert this now. This same as saying 0.3. This is centimeter. How do we convert it to meter? We're going to divide it by what? By 100. That's 0.3 divided by 100. 0.3 divided by 100. We can say 3 times 10 raised to power minus 3 all square. This is square. So F now will now become now. Let me this thing. I know you'll be saying, where about the minus and plus? We don't need the minus and plus. Minus and plus, I'll tell you where we need it, but for now, to get the force, we don't need it. The minus and plus just help to tell us about what nature. Are you seeing that? So first of all, carry your calculator, press it, and get the answer. And if you do this very well, you're going to get 18,000 watts Newton. So the force is 18,000. Now the next thing is, the question is not just asking us force. What is the force and the nature? The nature now talks about it is positive and negative. What is about positive and negative? They are what said to be what? Attractive. So it is 1,800 and attractive. Or you say attraction, let's but use the word attractive. How do you get attractive? Because opposite charges, like charges repel, unlike charges what attract. So do you understand? So at every point, know that that's why Newton will say the force of attraction or repulsion. So it is either attraction or repulsion. Do you understand that? Let's take another past question. Where you see that the force of attraction, the force of repulsion between two positive charge was given as 5 microcoulomb. His microcoulomb separated by a distance. And they're given what will be the force of attraction. Of course, we know that force is given as K Q all over R squared. So mean that the force was given as what is K? 9 times 10 raised to the power 9. Or let me write it here. The force now give 9 times 10 raised to the power 9 times your 5 times 10 raised to the power minus 6 times 8 times 10 raised to the power minus 6 all over your 0.02 all squared. For me now, force will now because if you do this very well, if you die, you're going to get 900 Newton. And that's the same as saying 9 times 10 raised to the power 2 Newton. Now, what's the nature of the charge? Of course, you see that the force of is already repulsion. I mean, they have same charges. Because look at it, they say they have 2 points, both of them are positive charges. So it is this and what repulsive. Do you understand? But they are really asking for the force in this one. So making what option without option C becomes the what answer. Do you understand? Very, very what simple. Now, if you say you understand, let's see more past question.
Now that you have created your account, right? For you to start learning, what do you do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they are all there for you, right? What do you do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your JAMB syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? what happens is that you click on it. Immediately you click on it, you see all the classes will display. History of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cell immediately. Your class will start playing for you. Shey easy and now. It will start playing for you easy and direct. And what happened? You can even choose to make it full screen. Right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use Nightsoft just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it start loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following. The answers are there. Number one answer is B. Why is the answer B? It is explained for you in details. Every singular thing. And then you are following your classes. You are done with that. You come to the next. You see your notes. Everything structured and organized to the core. In fact, at the end of the day, there is a blow kiss for you. You have done well. Get out. You too much. Everything is structured and organized for you in the app. Right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and all of them are in line with your JAMB syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down right on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your Waec cell or the JAMB question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosome. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your JAMB 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
We're told that JAMB 1985, if the distance between two stationary charged particles is doubled, the magnitude of the electrostatic force between them will be. Now, that's a relation question. If you're following me, you should know that we have talked about relation many times. Now, they're talking about if the distance, they're talking about distance and force. And according to Newton's Coulomb's law, we know that force is equal to Q all over R squared. So they're only focusing on force and distance. So we can say F is equal to K all over what? R squared. So remember, what will be K? K will be equal to what? F1 R squared 1 is equal to F2 R squared 2. Are you seeing that? So the question is, if the distance between the two charged particles is doubled, what to be the force? That means the distance is doubled. That means let's take all our F1 to be 1. That means force 1 will be equal to 1. R1 will be equal to what? To 1. Now, You now say if the distance, that means R2 will now be R2 double, that's 2 of R1. What's 2 of R1? That's 2, right? R2 is 2. Now what will now be the first 2 which you are looking for? So putting that equation now, this equation, using this equation, that's going to be, what's F1? F1 will be 1 times 1 is equal to, what's our F2? That's what we're looking for, F2 times, what's our, remember that R2 is 2 all square. Yeah, there's supposed to be square, but square of 1 is 1. So this means that saying 1 is equal to F2. 2 square is times 4. So what will be F2? F2 will be equal to 1 over 4. Are you seeing that? So option A said to be double, B said to be half, C said a quarter of its former value. Look at it here. That means 1 over 4 of that of the former value. This is correct. So this is unchanged, making option C to become the what answer. By now you should know relation. If you have been following my class, if we study relation from motion, gravitational elasticity, we talk about relation. Relation is very important in physics. Post physics. This is a 4 times the original side. No, it is 1/4 of the original, not 4 times. Do you understand that? Quickly, let's see another question. We're given 3 charges, 10 Coulomb, 20 Coulomb are distributed in a figure. What is the resultant around 10? That's plus 10 charge. So what's the resultant around plus 10? Now in this one, you have to settle down and pay attention. Very simple. What are we going to do? This is, we're going to name this side our first one. So this is the distance between 2 charges, 1 and 2. The distance is 3 meters. We're going to name it our first 2, where this. And the question say, what will be resultant around your 10? So I'm going to take it like this, so I can name this as the what? As the theta. First of all, let's get the resultant. So what will be F1? F1 will now be equal to KQQ all over R squared. Are you seeing that? So F1 will now be equal to K, that's 9 times 10 raised to power 9 times between that's 10 and what? 10 times 20 all over what's distance? 3 all squared. So we're going to get our first 2. What to be? We're going to get what? First 2 also be the same thing. KQQ all over R squared is equal to 9 times 10 raised to power 9 times 10 times 16. We're not putting the sign. Don't put the sign, is just to show the polarity or the nature of the charge. So what will now be our new diagram? A new diagram will now be something of this nature. So our F1, calculate F1, calculate F2. So quickly, if you do that now, you're going to get 2 times 10 raised to power 11 Newton. Here we're going to get 3.6 times 10 raised to power 11 watt meter. So this is the first one, while this is the what? First 2, right? From here now, we can get using resultant of vector when they are inclined at right angle. So if we take the resultant like this, so this is our F1. This, if we balance this, will be our what? Our F2, right? And if you use this to be our F2, if you balance this become our what? Our F1. So any of them we are using, but we are using this inclined angle, so to be what? To be theta, right? So if we are using that now, everybody, what become the resultant now? F. Let's call this resultant F. F now will now be, according to Pythagoras, is going to be the square of what? F1 square plus F2 square. Are you seeing that? The question says calculate the resultant and the nature, that's the degree of the force. So how do we solve this now? So F here now because what's our F1? That's 2 times 10 raised to power 11 all square plus 3.6 times 10 raised to power 11 all square. Then we take the what? The square root. Let me write it here. F now will now be equal to 4.12 times 10 raised to power 11 Newton. Please always confirm with your calculator. So this will be the what? The resultant. But we are not done. We also need the angle, because the question it's not just talk about when you are giving such, you calculate the resultant first and also get the angle. Now, how do we get the angle? So let's go back and let's try to draw that diagram. Now let's see, we have something of this nature to be our F1, and we have this to be our F2. Say this will be our resultant. So we're going to balance here, here becomes the angle what? Theta. So this will be also be our what? Our F1. Now from your SOCA to about if you are used to scalar and vector, you should know that to find the angle it will be tan. But look at it, this will be the opposite, and this will be the what? The adjacent. So our now become tan theta will now be equal to F1 all over F2. And what was F1? We got 2 times 10 raised to power 11. And what's our F2? We got so that become 3.6 times 10 raised to power what? 11. 10 raised to power 11 will cancel raised to power 11. So our tan theta is the same thing as saying 2 all over 3.6. So what will now be theta? Theta will be equal to what? To tan inverse. That's tan inverse. So if you do this, if you divide this, you're going to get 0.555. Theta will be equal to 32.28 degrees. So that's just it. Just settle down. You first of all get the resultant angle. This is especially for those writing WAEC. You get the resultant angle. You also get the what? The angle which is the what? Theta. Do you understand? Post it, go through it. I'm also going to give take this one as assignment. The question will say what is the result between 1, 2, 3 and we're giving acting on 2. So use this as the word assignment. I hope you understand it. Just post it, take it at your pace. There are a lot of questions in the words in the note. I'm going to see you in the next class. Go through the notes, go through the meeting. For those that want to join the 350 gang, belong to our WhatsApp word community. I'll see you in the next class where we'll now move further to talk about our electric word field. We've talked about electric field before, but we'll now talk it in respect to Coulomb's law. Do you understand? But for now,
Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.